This is Samira. Welcome to session on routing concepts. In this session, I would cover routing basics, that is, what is routing and what are few of the parameters that are being used by the router to perform routing. Then we will take a look at the entire routing process, that is, if one of the devices on a network tries to ping some other device on some other network or on the same network, what are the different steps that would happen in order to route the message from the source to the destination. Next, we will take a look at the different ways of building the routing table being used by the router. One is static routing, other is dynamic routing. So, what is the difference between static and dynamic routing? Then, we will take a look at a few of the terminologies that are being used in routing. And finally, we would cover what is IGP or Interior Gateway Protocol and what is EGP or Exterior Gateway Protocol. So let us begin with the session. Let us move on to routing basics. We'll first take a look at what is routing. When you want to send a message from a source to destination, routing basically means finding out an optimal path for sending the message over the network from source to destination. In order to find out the optimal path to move from the source to destination, routers would be using some kind of a protocol to perform routing. The routers can route the packet to the network based upon the destination network IP address present in the IP header, the possible routes to the remote network. The routers need to calculate the best route to the remote network based upon the possible routes, and the best route would be mentioned in the routing table which is present with the router. The routers need to maintain and verify this routing information, and the verified routing information is put in the routing table. If you are using dynamic routing, then in that case, the neighboring routers are the ones from whom the router is going to learn about the remote networks. We are going to take a look at the details about what do you mean by static routing and dynamic routing in later slides. First, let us take a look at how the routing process takes place. So for instance, if you have got host A present on 172.16.10.0/24 network, and you have got a host B which is present on some other network 172.16.20.0/24. Now in order to send a message from one network to another network, you need a router to perform routing. Consider an example wherein the host A is going to ping host B. That is, at host A, the user is going to write the command ping 172.16.20.2. Ping uses ICMP protocol, which is Internet Message Control Protocol. The ICMP protocol is present at the network layer. Okay, so as soon as the user is going to perform ping operation, the network layer present at host A is going to create an ICMP payload. So this is going to get created by the ICMP protocol which is present on the upper part of the network layer. The ICMP payload is going to be sent down to the middle part of the network layer to IP. The IP will encapsulate the ICMP payload in the IP header. The IP header is going to contain the source address and the destination address. The source address is the address of host A, which is 172.16.10.2, and the destination address would be the address of host B, which is 172.16.22. Along with creation of a packet, The network layer is also responsible for performing routing. For this, the network layer is going to make use of the routing table which is present in the device. The routing table is going to contain the destination network and information about the next hop in order to reach the destination. Okay, the next hop is basically the directly connected hop. Okay, so whatever is directly connected to host A is going to be there in the next hop. So this interface is directly connected to host A. Okay, and host A needs to send the message over to this interface in order to reach this network. Okay, otherwise there is no other way to reach this network. Okay, so that is what is going to be mentioned in the routing table. In order to reach this destination network, okay, not the host, but this entire destination network, the router A needs to send the packet to this interface. So this interface becomes the next hop which is mentioned in the routing table. Okay, so the network layer is going to read the routing table and it is going to pick up the next hop information from the routing table. The next hop information along with the packet moves to the lower part of the network layer in which we have got the ARP protocol present. ARP is Address Resolution Protocol. Address Resolution Protocol is going to resolve the next hop IP address to the next hop MAC address. For this, the ARP protocol is first going to take a look at the ARP cache which is present in the device. If the ARP cache has the resolution, the ARP protocol directly uses the MAC address which is present in the ARP cache table. If not, the ARP protocol is going to be used in order to resolve the IP address to MAC address. Once the MAC address is being found out by the ARP, the next hop MAC address along with the packet is going to be sent down to the data link layer. Data link layer is responsible for creating this frame. The data link layer basically appends a data link layer header to the packet along with the trailer. The data link layer header contains the source MAC address, that is the MAC address of host A, and it contains the next hop MAC address. Okay, so note here that it is not the destination MAC address, it is the next hop MAC address which will be present in the data link layer header present here. Okay, the next hop MAC address is going to be received from the network layer, right? And that is going to be used here. And the frame would be sent to the physical layer. The physical layer will convert the bits to signals which are understood by the transmission media and the signals would be sent over the transmission media, whichever device is present. So here we have got the router which is present on this transmission media. So router is going to intercept the bits or the signals which are present on the transmission media. The physical layer which is present in the router is going to convert the signals to bits and send to the data link layer header. Once the data link layer receives the bits, the data link layer can understand the format of the frame and it can read the data link layer header which is present in the frame. Okay, so first the data link layer is going to read out the trailer and perform the error check. If there is no error present, the data link layer will read the header. Okay, the data link layer header contains the MAC address, which is going to be the MAC address of this interface itself, okay, which is the MAC address of the router. Okay, so the router is going to understand that this frame is destined for it. So the data link layer present at the router will strip off the header and trailer, will remove the packet out and send the packet to the network layer. When the network layer receives the packet, the network layer understands the packet structure. It can read out the IP header present. In the IP header, the network layer can read the source address and the destination address present. The destination address, which is the destination IP address, is not the IP address of the router. Okay, it is the IP address of host B. So the network layer will understand that this packet is not destined for it. The network layer will then take a look at the routing table, which is present with the router, and it will check if the destination network for the destination address mentioned is present in the routing table. If it is present in the routing table, it will check the next hop in order to go to this destination network. The router will check that the next hop is directly connected to itself. So it is going to send the IP header along with the payload, that is the entire IP packet as it is, to the data link layer along with the next hop information. Okay, so the data link layer, the network layer is going to send the next hop MAC address. Okay, after the ERP is going to resolve the next hop, which is the host B itself, to the MAC address. So basically the network layer here is going to send the packet along with the MAC address of this B to the data link layer header. The data link layer is going to create a frame, and then this frame is going to be sent to the physical layer. The physical layer converts bits to signals and send it over to the host present here. When the host receives the bits, the data link layer is going to create the frame structure. It will read the data link layer header, wherein it has got the MAC address, which is the MAC address of itself. So it will understand that this frame is destined to it. The data link layer will strip off the header and trailer and send the packet to the network layer. The network layer will recognize the IP header. It will read out the IP header in which it has got the destination IP, which is the IP of host B itself. So the IP present at the network layer will understand that this packet is destined for itself. It will remove the IP header and then send the ICMP payload to the upper part of the network layer, that is to the ICMP protocol. The ICMP protocol will recognize that this is an ICMP echo request message, and the ICMP protocol will generate an ICMP echo reply message and will send it to the IP layer, that is the middle part of the network layer, which will convert it to packet, and then it will go down the OSI model back to the source. Okay, so this is how the routing is going to take place when the source is going to do a ping to some destination. Now, in order to create the routing table, there has got to be some way. So there are two ways in which the routing table can be created. You can have routing table created using static routing, wherein the routing table would be configured manually by the network administrator. That is, the network administrator is going to make an entry manually in the routing table. That is, in order to reach this destination, this is the next hop to be used. In order to reach the second destination, this is the next hop to be used, and so on. So all of these entries are going to be made manually by the network administrator. Okay, since the network administrator is going to make the entries manually in the routing table, the network administrator is the one who is going to be responsible for updating any changes that occur in the network. Okay, that is, if one of the device or one of the router fails, then in that case the packet should be routed over some other path. This information has to be manually entered by the network administrator in the routing table. Okay, so as and when there are changes happening on the network, the administrator should be aware of it, and administrator should update the routing table present on all of the routers in the network. And hence static routing is not feasible over large networks. If you have got very small networks, you can use static routing only if you require some amount of security or some amount of an administrative control over the routes. Otherwise, it is always a good idea to use dynamic routing. In case of dynamic routing, the routing table is created automatically by the routers. For this, the routers are going to exchange some advertisements amongst each other. And depending upon the protocol that is being used, the protocol will communicate with the neighboring routers if you have got same protocols being configured on the two neighbor routers. Then using certain protocol, the routers would be able to speak to each other in a common language and would be able to understand new routes from each other. And this is how the routers would be able to update their own routing tables and create the entire routing table automatically. If there is any change occurring in the network on which you have configured dynamic routing, then in that case, the routing protocols themselves would automatically inform the other routers about the change, and they would themselves update the routing table. Okay, so there is going to be no manual intervention required if you use dynamic routing. Let us take a look at the routing table which is present on the router. So I have created a small topology here wherein I have got two devices which are directly connected to two interfaces of my router. So these two devices are present on different networks. In order to take a look at the routing table of the router, I need to use the show IP route command. We have seen this command in our previous session. If you have not looked at the basic commands for the router, then please take a look at the Cisco iOS video and then move on to this. So I have used the show IP route command on my router. This is the routing table that is present on the router. I have not created any routing table, but this is the default routing table which is present. In the default routing table, we are going to have the directly connected route information present. So my router has got two directly connected routes. One is present on the fast Ethernet 00 network interface, and the other network is present on the fast Ethernet 01 interface. So this information is going to be present by default on my router. If I would have configured either static routing or dynamic routing on my router interface, then in that case, the routing table would contain those routes in addition to the directly connected routes. In case of those routes, the routes will also have a metric called as administrative distance. So let us take a look at what do you mean by administrative distance. Administrative distance is used to rate the trustworthiness of the routing information which is received by the router from a neighbor router. Administrative distance is an integer from 0 to 255. If the administrative distance value is 0, that means this route is the most trusted route. Okay, that means this route is the best route. Whereas if the administrative distance is 255, it is the least trusted. Okay, so it ranges from 0 up to 255. Static routes have got administrative distance of 1 by default. That means static routes are going to be more trusted as compared to other routes. An example, the dynamic route RIP has got administrative distance of 120. Okay, so if my router receives information about a particular network, okay, so if I have got two routers which are neighbors of each other, okay, and I have one of my router which is connected to network 1, and this router is going to send information about network 1 to other router. It is possible that I receive multiple routes to network 1 from multiple routers. Then in that case, my router is going to compare the administrative distance of the multiple routes to network 1. If my router has received the route to network 1 from 2 routers. One of the router has sent a static route and other router has sent RIP route. Then in that case, my router is going to select the static route information. Okay, so that is where the administrative distance would be used in order to rate a particular route for its reliability. Next, we will take a look at something called as an autonomous system. Autonomous system is a terminology that you would be hearing in case of your networks many times. An autonomous system is basically a collection of networks under a common administrative domain. So here you can see an example. If I have got some devices, okay, these are my network devices, and all of these network devices are administered by a common administrator. For example, this is administered by your company. Okay, so this is company ABC administering this network. That means these devices which are present are all present under the same administrative control. Hence, they would be belonging to the same autonomous system. Also consider I have got some other set of network devices which are under the administrative control of, say, company XYZ. Then these devices do not belong to the same autonomous system as the devices belonging to company ABC. Okay, so these devices are going to be under a separate autonomous system. So if you have got devices present on different autonomous system which want to communicate with each other, then in that case these network devices will not be able to send routing information to each other by default. You need to use some kind of a protocol called as exterior gateway protocol on these devices. Then only they would be able to communicate the routing information of their networks to the neighboring network. If you want devices only within the same autonomous system to be able to communicate with each other, then simply use the interior gateway protocols on all of these devices. So that is about interior gateway protocols versus exterior gateway protocols. Some of the examples of interior gateway protocols include RIP, OSPF, EIGRP, ISIS, and so on. For the case of exterior gateway protocols, BGP or Border Gateway Protocol is the most widely used EGP. For the purpose of CCNA, we are just going to take a look at the interior gateway protocols, not the exterior gateway protocol. We are going to take a look at an example wherein we have got two different interior gateway protocols being configured for two different autonomous systems. So if I have got network devices present under the autonomous system 1 who wants to communicate with the network devices present in autonomous system number 2, then in that case, if I am using only interior gateway protocols, I will need to use something called as redistribution in order to redistribute the routes from one IGP to another IGP. So we are going to take a look at redistribution as well in the later sessions. That is all for this session. Thanks for watching. If you have any comments, please leave the same in the comment section. It will help me to create better videos for you.